Do we start? Avantika, do we start?
It's just loading. It's taking a bit of time, sorry.
Are we live?
Yeah, we're live. Do you want to maybe try sharing just your slides?
Yeah, I mean, I'm already on the slides.
Okay, yeah, perfect. Okay, so hi everyone, welcome to the NMRA sixth session, and today's session is our sixth session of the Systematic Review and Meta-Analysis lecture series. And today's session is on data extraction and synthesis in systematic reviews and meta-analyses. Today our speaker is Neeraj, and he's the founder and president of the NMRA. He's a current PhD student in cardiovascular science at the University of Leicester and a previous medic graduate from UCL. So I'm just handing over to you now, Neeraj.
Cool, thanks. Hi, everyone. So we're back for the NMRA Academy. Welcome to all the prospective mentees and to anyone else joining. So for today's session, we're going to be doing systematic review, data extraction, and synthesis. I've kept it quite brief because I feel like this is a topic that is best done with practice rather than me telling you how to do it. But I've tried to include as many examples from like previous papers we've done in NMRA and or I've done myself to try and illustrate how that's going to look. So just to start off with, as usual, I kind of give you guys a bit of a background. So NMRA, I founded in 2022. It's a non-profit trying to give students, young academics, doctors, anyone who's keen to get into research but is struggling to do so, the platform by which they can achieve that by breaking down barriers to research entry and facilitating you guys to get involved with opportunities for development, skills, networking, and the confidence to really do independent projects that will very much in the same spirit as a mentorship scheme. You can come up with your own ideas and you can fulfill them and hopefully add to the literature by the end of it. Just to put this on the screen, this is kind of the overall line for the Academy. As usual, every single Thursday, 6 p.m. So at the moment, we're on number 6, data extraction and synthesis. What we have left is meta-analysis. We're going to talk through how to do it, give you all the steps and examples. Then we're going to do interpreting the results and writing it up. And then the last session is just getting your paper ready for submission. So it will be a full whistle-top tour of everything you need to know by the end of it to do your systematic review meta-analysis. If you're going to be on the mentorship program from hopefully next week, then you guys will obviously just jump straight in. You can essentially, you'll be able to follow through again everything that we've done because you will be doing the work that's involved in session 1, such as finding a research question, and then you'll kind of work through all that anyway. So hopefully you've already got that knowledge a little bit in advance, and then you can just work backwards and keep ahead of the curve. But yeah, this is all stuff that I've covered before. It's just a recap. The main meat of today's session is what do you really do to extract and find the information you need out of those papers? And then how does that turn into something you can synthesize? So from the previous session, we've kind of established that you're going to have, because you've screened, and then from there, you will have identified which ones are most relevant to your systematic review meta-analysis based on your inclusion-exclusion criteria. And then from there, in my session, I also covered how to risk of bias. So you will be able to identify how good those studies are in terms of, do they have bias? Do they accurately represent the literature? Are the trials well conducted? Is there a lot of variation within them? You will be able to make those judgments and you'll know how good the literature is that's going in. So with that foundation, the next step is let's go and find out the relevant information in those papers so we can start to put our review together. So extraction is quite a simple process. When I start talking about it, you'll start to see that it kind of mirrors your research question and it mirrors what you want to get out of the review itself. So this is the checklist that comes from the Cochrane Handbook. I can't recommend enough how much you should at least have a cursory knowledge of the Cochrane Handbook. It is quite lengthy and in a lot of detail, so you don't necessarily need every single step and every single letter and dot. You don't need to go into every single word of it necessarily, but knowing the content and the principles behind the high quality evidence that it perpetrates is really going to help you. So now this is a kind of a mess of all different types of things that you can find in a paper. If you read through a paper, you will find all of these things in various places, but there's kind of a method to the madness here. So what I'm going to do right now is just going to break this up into little chunks, and you will start to see why I'm doing that, because that's what you're going to be presenting in your work, in your study. So the first chunk is this kind of starting point. It's about the study. It's about what kind of design it had. It's about, how was it conducted? It's where did it come from? It's very much the kind of the metadata. It's the information about that study and how it was. You'll also notice that all of this stuff, design, sequence allocation, blinding, all this stuff, this is essentially your risk of bias analysis. So while you're doing it, you can start to tick that off as well and do two birds with one stone. That's going to be really helpful just to keep your work as efficient as possible and to make sure you're not overdoing things unnecessarily. Because the last thing you want is that you spend all the time to read a paper to the risk of bias, and then you end up having to go back again and do the whole thing again just to go and get the rest of the data. So it's just an inefficient way to do things. So this essentially would form your study characteristics. You're going to take all the key information about the study in terms of who the author are, what kind of study design it is, whether it had, what level of follow-up it had, whether it was a blinded study, prospective study, whether it was a observational study, all these kind of things about how the study was conducted and what kind of methodology it uses. So that will then guide the reader in terms of where your data comes from and what kind of papers are constituting it. So that's very important, because a reader will need to know what forms the basis of your systematic review. And that will be essentially the first table in your results section. You're going to kind of illustrate all of these in a nice table, but first off, you're going to extract it from all the studies. Then once you've done that, you covered the study. The next thing you want to talk about is what the study is about. So the next chunk is all about the participants. You're going to tell them the number of patients, where they come from, the country they're from, whether they're from a hospital or from a primary care setting. You can go to like demographic factors, age, gender. You can talk about deprivation, ethnicity, whatever is appropriate to the question you're answering. It might also be helpful to go into like comorbidities, so things that are associated with what you're studying, because that might help you to indicate how unwell these patients were and whether that affected the disease you're studying. This will, again, you have to think of this from the perspective of your research question, but also from the reader who's trying to understand your question. They need to know what the patients were that were being studied and what that's going to constitute for the analysis that you're going to do. So that's going to be your table 2, your patient characteristics. I put participant because some trials don't have patients, and so it's just a bit more broad. So that's table 1, table 2. In most meta-analyses, you'll start to see this, and I'll give you a couple of examples in a second. So that's table 1, table 2. The third table, and this is not necessarily a table, it can also just be your meta-analysis, but this is your outcomes. So this might be, your mortality rate, it might be the risk of a disease happening, it might be how it was measured, and you're going to talk about that data is where it comes from, how it was measured. You're going to, and you might even put down like any p-values. If there's comparisons being done, you'll put down what the comparison was. It might be an odds ratio, it might be a hazard ratio, it might be just percentage differences. Whatever that is, you need to note that down so that you can then go back and talk about it later, or potentially you're collecting that data so that you can then go back and do a meta-analysis of all of those studies. So it's very important to look at outcomes, but also this is where you have to be very thorough. So you want to have as much detail as possible. You want subgroup analysis, you want how long the follow-up was, you want what the measurement unit was, you want if there's any difference in outcomes. So, you might have outcomes being measured as a percentage in some studies, but as just a raw number in others. You need to make sure that it's consistent wherever possible, and that if it's not consistent, you can note down what it was measured and why they're different. So these things are really important. You will notice there's kind of a chunk at the end for miscellaneous. So it's got like funding, it's got comments, references to other studies. Those are for your own interest and potentially for things to talk about in the discussion section of your article. They're not things that are directly going to go into your results necessarily. So that's why they're kind of extra things that if they come up and they're appropriate, note them down, but they're not necessarily going to feed into a table as clear cut as these things. Also, you have a table 1, a table 2, and a table 3. So these are very clear cut, and that's essentially everything you need to data extract. The majority of interventional studies and studies that have very clear defined inclusion and exclusion criteria and a clear thing that they're trying to measure, this will be enough. Let me show you an example. But actually, so I'll come back to that in a second. Yeah, just as an example. So study characteristics, it's got, where the study was done, what kind of technique was used, what kind of follow-up they had, what the population is in terms of what the sample size. These are your kind of standard study characteristics. It's the stuff that defines what is that study looking at. Now, this paper was a meta-analysis we did, so you'll notice there's a lot of numbers, which is not necessarily going to be the case. When you do data extraction, you might find that you have to pluck out like pieces of text from tables or from actual work that you do. Also, obviously, this is a table from a paper itself, so there's kind of like both steps of extraction and synthesis already occurred, but here there's nothing we do synthesize, right? Like if the study tells 84% of them were male, that's it. There's no more additional synthesis needed. Just what you're going to report. So in this case, I hope that that's clear that this is essentially just straight from the extraction. 2 we have here is again demographic characteristics. So we've talked about like comorbidities and factors. We've talked about what kind of drugs the patients might be on. This is again to give a reader an idea of, well, within this study, yeah, you have all the different patients, but do they have different drug characteristics? Do they have different risk profiles? Are they all genuinely representative of what you will find in the real world? And if you know this information, you might start to see differences, and you can start to say, well, hang on, this study has 88% hypercholesterol, 8. Does that make a difference? Clearly it might do, because drug medications that the patients might be on will be different, and the way that we treat them might be different. They might have different outcomes. They might have interactions between drugs. All these things are important to know about, because as a reader, you're thinking, well, why did they did what they did? And how is that going to impact me reading this paper to apply to my patients? A lot of research, the trick behind the best research is it's done with an end user in mind, and it's done in order to help them with a specific research problem. So it's very important to kind of give this kind of context and make sure that whoever's reading your paper understands these things. But yeah, as I've kind of prefaced before, we did a meta-analysis in this paper, so there's no table 3, because the outcomes, we just analyze them and we'll just make forest plots out of the various things that we covered. So you wouldn't present it as a table and do a forest plot. You don't need both. It becomes counterintuitive, and you're just taking up unnecessary space within your paper. Another thing to notice is the use of the NR. So if the study doesn't include data, you just put NR. And that's not a hard and fast rule. Sometimes there are ways around it, which I will talk about. But in our case, we just said, well, if the study doesn't have the information we need, we can't produce it. So we're just going to accept that there's a limitation and that data doesn't exist for us. So that's completely fine because it's consistent. It's something that we kind of decided beforehand and we didn't go back on it. And as long as you're consistent with what you choose and you're very transparent about why you're doing it and the reasoning, that kind of decision makes sense to a reader because they'll say, well, fair enough. Like, if you can't find the data, then don't worry. Well, what can you do? However, there are ways that you can get around this. I'm just going to backtrack a little bit and talk more about the process of data extraction. So this will make more context. So just going back here. So just like when I was doing screening, this is all you need to know about the process of extraction on like an overall raw sense. It's done by 2 authors, at least independently. And if there's any discrepancy, you need to have a mechanism by which you're going to resolve it. That often is just by talking it through between the authors who are doing the screening. Maybe one of them missed something. It might be human error. It might be that they looked at different data sources. That should be kind of pre-discussed and potentially mentioned within your protocol so that it's very transparent what you're doing. And then when you extract, you're going to extract pre-specified things that you want to take out of every single paper, and you will have a pre-prepared table or a spreadsheet into which you'll collect that. Now, before you look at the papers, what do you want to collect out of them? In the majority, sometimes there are things that you might find when you read the papers and you'll be kind of, it's unexpected. And you think, actually, this will be helpful to add to my study, which is fair enough. Like you can obviously spontaneously add things in sometimes, but you kind of don't want to do that. And I want you to kind of think amongst yourselves, like, why would that be the case? Is there a reason that if you don't pre-specify and you just pick out what you want out of papers, that might not necessarily be the best research practice? Just have a think amongst yourselves, maybe put some answers in the chat and discuss if you want. But yeah, sometimes the other thing that can be really helpful, and this doesn't breach what I just said about pre-specifying you can trial a spreadsheet when you're kind of experimenting and seeing what you need. Just do it on like a small pilot sample of studies and see that you're actually getting all the relevant things you want. And at that point, if you chop and change, it's not the end of the world because you haven't committed a certain way of extracting data. You're just trialing it on like maybe 2-3 studies or whatever. That's not the end of the world. So yeah, that's pretty much everything you need to know for extraction. There are a few things you should kind of bear in mind in terms of planning ahead for common problems. So missing data, big one, which I kind of showed you in that table. Sometimes, if you have 10 studies, not all 10 of them will have the exact same variables and the exact same. And so you might have that some of them are different, or potentially you can start to, kind of think about some solutions. So sometimes you can work backwards from other presented data. So for example, Kaplan-Meier curves are for survival trajectories. Sometimes there are tools that you can put the image into and essentially get like an estimate of what that data would have been, because it kind of calculates it backwards just by interpreting the graph really carefully. Sometimes if you have like a mean and standard deviation, you can start to work backwards and figure out, like, you can transform that into a median, and you can figure things out that way. Or alternatively, what you can do is you can contact the authors who wrote the original study and say, well, can we have your raw data, and fill in the gaps from there. You might see that mentioned in a few trial protocols and things. So like meta-analysis of trials, they'll mention that. It's not something that happens very often, and it's not always fruitful, because there's a very reasonable chance that the reason they didn't include it in their study is because they don't have that raw data, like that it doesn't exist to report, right? So that's something to be mindful of. The other thing that you have to think about sometimes is difference in outcomes. So you might have outcomes using different scales. Maybe they've measured things with different units, And sometimes that can be confusing. It can be challenging to interpret. So a potential solution that you may document within your protocol and conduct is a transformation. So you might then you can then use a statistical tool or a formula and make sure that maybe all the variables are in the same units, but after the transformation, so that it's consistent. And that's really good. And that will then allow for you to you can present cleaner data that's more refined and more appropriate. And the last one that I think is quite important, I think people get this a little bit wrong sometimes, is sometimes you can over extract data. Like I've seen people who will literally put a paragraph from a paper, just directly copied and pasted in. And that's not always very conducive to good research practice, because you need to be more specific in terms of what you're including and why you're including it. It's not as simple as just saying, well, this is relevant in terms of it's mentioning the same thing as I think that is in my table, so I'm just going to put the whole thing in. You need to really nail down like specific data points or specific sentences and phrases within the paper you're reading that will then guide you in terms of exactly what you need and the exact specific data you want. And this can be quite challenging sometimes when you have two different reviewers. Sometimes maybe someone's like just read something from the abstract and just put that in, but the other person may have copied and pasted a chunk out of the method section. So now you've got to say, well, did one person under extract and just didn't have enough information because they only looked at the abstract? Or maybe they were just being succinct and taking out like a really specific thing that was mentioned in the abstract, and the other person's just gone above and beyond and taken way too much, which doesn't have the appropriate context and is not necessarily what you needed for answering that specific type of research question and getting that specific data you wanted. So again, that's where you need to be confident that you're going to look at the same things and you're going to be very specific about what you want and why. Cool. This is just for some context. So when you write in a protocol, this is last week, we were very detailed about it's going to include country, it's going to include level of evidence, journal, very detailed about what's, and we're also going to give a breakdown of where that looks like. So these are the sample tables authors will be using and filling in accordance with this protocol. And that level of depth really helps because it shows a reader exactly what we did, exactly what we took out of all the studies. And like I always say, right, the best research is the research that can be replicated. You could go and take these tables and fill them out yourself. And if you've done it right and we've explained it properly, you should get exactly the same stuff that we did. And that will show you that that was a really high quality, well conducted systematic review, because it's so systematic that you can copy it. And just to illustrate, here's the rest of the tables we've included. So it's got, again, authors, interventions, well-being attributes, everything that we included what's in the table. And that is, it shows again all that's pre-specified and exactly. So that's that. Now, this is from a paper. We've got the accurate release of the outcomes, the first kind of the outcome, and we go on to say, well, you need the recommendations. So these are the patients. That's your table 2. And this would be a table 3, but we did a meta-analysis. So this, and that's what's in my slide. Like that is you cannot not do that. These are a must. And we just mentioned, if data was not reported in a study, we just assume it's missing. And again, this is what we showed in these tables. If it's not there, we just assume. And because we specified that's what we're going to do, it's consistent, and that's really the crux of it. So yeah, that's in a nutshell all you need to know about the process of doing a data extraction. So yeah, it's really that simple. Like, just you need to pick out what you're going to collect, make your tables, and then as long as you're happy with the research question being appropriate and you're happy that you're collecting all the data you need in order to do that, you'll be fine. And again, I've given the example tables. There's some example write-ups. So when you get to that stage in the mentorship program, you're more than welcome to kind of take some in this stuff and get an idea of what exactly you need. Cool. So data synthesis. I don't think I do have any questions actually before we go into this. Thanks. Sorry. Is there a folder anywhere with the slides with all the presentations so far for future reference? I don't think so. I haven't made one, but all the recordings do get uploaded eventually. Metal takes its time sometimes, so you can obviously just flick through that and see the slides that way. I will try and I can try and put up some of mine and ask around for them, but I can't promise because obviously some of these aren't mine and other people have come in and presented, so they might not necessarily be keen to give slides out. But I can ask the question for sure. Cool. Okay. So just kind of getting back into data synthesis, there's two main ways to do it. So there's qualitative, which is kind of a narrative synthesis. You'll see that term used a lot in kind of qualitative studies, things that are looking at more broad, like they're basically any study that doesn't have a blatant meta-analysis will probably have some variant of narrative synthesis. And then the other one is obviously quantitative, which is your meta-analysis. I'm not going to do meta-analysis today because that's Connor for the next 2 weeks. He's going to be going into all the depth of that, so I won't tread on his toes. Yeah. So the type of synthesis you do essentially just depends on what data you have. If you have very clearly just been given a lot of, patient outcome data in terms of 20% of people died in X trial and 21% died in a different trial, and if you have a lot of numerical data that has been quantified for hard outcomes like that, you're pretty likely to end up doing meta-analysis, provided that the data actually lines up appropriately, it's consistent, it's all from a fairly similar pool of patients. As long as it makes sense to do, then quantitative is probably more appropriate. But in the vast majority of studies, it's not possible to do because you might find that the data isn't there like that. You might find that the study type is it's more conducive to qualitative study because you've done a survey, maybe it's based on interview data, maybe it's based on inconsistent data from that's numericals and doesn't lead to a meta-analysis. There are a number of reasons why it wouldn't make sense to pursue a meta-analysis. So in that context, the bulk of systematic reviews you read and you find will probably end up having some kind of qualitative analysis. And the process by which you synthesize all of these is very similar. So I'm just going to give an overview of this. And if there's any questions, or again, if you get to doing it in a mentorship program or in other studies and you find yourself stuck, come ask me any questions. But just to kind of give you a brief overview. So the main way we do this is via something called thematic analysis. It's a little bit confusing initially because the way this looks, and I'll talk through an example so it makes a bit more sense, but essentially you start off with finding code. So you look through a paper line by line and you pick out all the individual things that are being said, and you give them a code. So then after that, once you've done that, you're going to start putting the codes together to themes. So codes that are in common get put into themes, and then you then turn those into analytical themes in line with how you can group them up to answer your research question. Now that's really confusing, right? Because what's the difference between a theme and an analytical theme? And it's one of those things that takes a lot of time to get your head around. The truth is, it requires a lot of critical thinking, because you have to start to think about the argument of where you want to go with your review, what points will help you answer your question, and then as you develop that theory, you can start to put all the themes together and say, well, this will answer this question, and so forth. If you cast your memory back to the first session I did, you will remember the DAGs. I'm kind of skipping ahead, but the DAG kind of model gives you an idea of a hypothesis. It gives you a framework of what you're studying and what constitutes it. So in this case, for example, if you're studying the link between a teacher's salary and student achievement, you might say, well, an increase leads to morale being better, which obviously then leads to teachers trying harder and students having better material. Then the other one is a better environment, which then means that students do better. And you've got, then each of these arrows is kind of a reason, and then kind of a causal chain that then leads to improved achievement. But when it comes to studies that you're looking at, what you might find is that individual code refers to one of these things. So for example, you might read a study that points out that as a result of teacher salaries increasing, more able people are starting to teach. So that would be a code. You'd say, well, that's something that's been identified within the literature. And then from there, you might also say, well, actually, another thing that's been pointed out is that teachers prepare lessons better. And, maybe you might also say, well, teachers also employ a greater variety of pedagogical strategies. These are all individual little arguments and points that you will pick up in your literature. And as a good scientist, it's your job to start grouping them together and making that argument of why they're significant and how they may answer your research question. So you can start to put all of these ones on the right-hand side together and say, well, as a result of all these things, a teacher's salary increasing leads to them being better teachers. All the stuff on the left, you might pull together and say, well, because of that, students work harder. So your analytical ones, themes, are the ones at the bottom, because those are the ones that answer your research question, and these ones are the individual points that lead to that. So having a good DAG gives you a framework and a theory because you can start proving it right and wrong based on the evidence in your studies. So a good synthesis allows you to combine arguments together to prove your point, because fundamentally that's what you're trying to do, right? As a scientist, you want to prove a point, and you want to show that all this different varied literature combines with X, Y, and Z and brings you a brand new argument and a solution to whatever research question you're answering. I've kind of just mentioned it here. I've mentioned it here as well. But so you need, whenever you do this, your synthesis should answer your research question. And the way you do that is by thinking about what you're trying to achieve. So there are two main types of systematic review that you can cover. So the first ones are effectiveness. Now, that's essentially how good something is. So you might look at the effectiveness of a drug therapy at treating a disease. And then you can say, well, compared to placebo, this drug is 5 times better. And then what you've done there is you've determined both a direction of effect, so it's an improvement in their health, and also a magnitude, 5 times more than a placebo. Or it might be 35% of people take this drug, remission from cancer. That tells you something, because again, the direction, which is treatment in terms of improvement of health, and there's a magnitude, which is 35% of benefiting from it. So these studies, as you can imagine, often do lend themselves to meta-analysis quite easily, because there's often is, when you have and a magnitude, of the best way to analyze that is to quantify it, and that data can very lend itself to meta-analysis. Implementation reviews are a very different type. These are more your kind of overarching. We're going to think about the process by which stuff is done. We're going to think about if research is done effectively. We're going to look at, are there any barriers to something being implemented? Are there things that facilitate it being done really well? These are the types of questions you might answer with a survey or an interview, and you might go and ask people, well, what do you think? Or like, you might say, well, have you faced any barriers in doing X, Y, and Z? And because that information is more likely to be qualitative, it's more likely to need this kind of synthesis. So once you identify what your research is and what you want to contribute to it, you will start to see how you're going to synthesize it and how you're going to answer those questions. Because if you know you're going to study a bunch of barriers to whatever, doing good quality research, you're going to start to think to yourself, well, what's stopping people? And once you know what's stopping people, those are the things you're going to look at when you analyze your data, when you synthesize it. You're going to say, well, potentially, things like financial problems or a lack of education or whatever. Those are things that you're going to start to think will come up. And those are the things that you can then structure your themes around. And then when you write your paper, it becomes very simple, because you just write a paragraph on, well, XYZ study mentioned financial barriers, or XYZ study mentioned educational barriers. Those just naturally lend themselves to your write-up, and it makes your life a lot easier, because as a scientist, you want to present all of these arguments in a structured way. Well, this is your structure. Your DAG and your research question are your structure, because you solve all of this and put it all together, the reader is going to have that framework built in. They're going to know exactly what you did and what, and they're going to thank you because you solved the question. You went from here to here, and you put all the rest of it together in the middle. So that's why. But I want to talk you through an example. This is from a really good paper written a couple of years ago. This guy, he was doing his PhD, and he literally wrote a second paper. So he did the systematic review, and then he wrote a second paper, essentially analyzing what he did and how he got there. And it's kind of brilliant because it gives you an insight into how people think about doing these kind of reviews. So this research question was about shared musical experiences in dementia. So essentially looking at, well, for patients and carers, how do they share experience of dementia, and how does it impact them? So whilst this researcher was going through all the literature, this is the codes they came up with regarding how music can be supportive. They found that it can help. It's a common platform, can help with memory and learning. It creates a supportive environment. This is, they kind of segregated all of these individual themes that they're seeing in all the codes. They've all been separated out just from reading the papers. And from there, they kind of made this mind map, and they say, well, let's start to put this all together. You have, music, your learning. It can help with your understanding of communication and musical connection. It might even come together with mood and how you feel. Now, these are not necessarily 100% related, because being a supportive structure and then tying it back to memory and learning doesn't necessarily make sense. You might think to yourself, well, what's the connection? And that's where, when you go into themes, you can then start to put that together. So a really big one they've identified, which came up in 258 codes, is connection. So they've kind of mentioned connecting with memories, non-verbal communication, all these things. Here, music as a catalyst. So they've taken these kind of disconnection they made between the theme, the codes, and a potential theme, and then they've put it all together. So it all kind of brings itself together when you think about a bigger picture. Then another one that they've brought together, you can see here, is, they've said internalized haven, something that's soothing, that's predictable. And they've said, well, it's this idea of having comfort and boundaries. And this is a overarching statement they've made, which is based on their understanding of the literature and their understanding of what was mentioned within these studies. It's a whole study. It's not just 4 words, right? There's going to be a full argument that is presented within that study about why and what exactly the patients were referring to when they said this. So having that understanding and knowing where this comes from really helps you structure where you're going to go with it. And so you can kind of see that process of this person did the mind map, they went away, they looked at more literature, they talked to this PhD supervisor, and then they've kind of jumped across down into all of this. So that having that kind of connection and that understanding of the literature is what's really going to get you from A to B. The final thing they did was they went from themes to analytical process. Now, what you're going to immediately realize is that all of this work, all of this about supportive, becomes one analytical theme, which is that music can be a supportive structure. Because as you combine so much together, what you start to realize is that they're going to overlap if you're not careful. So you have to make them as possible, and each one of them should answer a very specific argument within your research problem. So they have completely separated everything apart, and they said, well, there's stuff about well-being in terms of shared activities. There's an ecological system. There's shared activities as they're experienced, and then also the fact that it's supportive. They've really tried to separate each individual analytical theme into its own unique chunk that does not overlap. Because otherwise, here we've got connecting, containing. Well, that might overlap with stuff like shared dyadic experiences. It might overlap with stuff like belonging, connection. You have to be certain that you're making one argument for one point, because if you overlap, it's going to get confusing. So that kind of process of really separating things out and nailing down what's being said for what seems like a really massive point with 536 codes comes one little thing at the end here. Just ignore that. Okay. And then another example, this is from the JBI systematic reviews. It's a pretty simple but helpful guide about how you can kind of start to get into data extraction synthesis. Give it a read if you want. So what they've done here is they're looking at a study of patient perceptions by scanning. So what they've done is they've coded it into different themes. So they found that people experience known, they found that it's different world, they found that submitting themselves to a medicalized context. So these are distinct things, but you can start to put them together into slightly more combined themes, and then at the very end you can synthesize the whole thing together into a full finding. Right? So you've got an alien experience, meaning in other words, swallow and sinking. That is what they're describing here, is that an MRI is nothing like any normal experience that they would have on a day-to-day basis. So, that's why all of these can be lumped into what is the closest possible description out of this world alien experience. And you'll notice that they kind of specifically reuse the words that were in codes so that they're not detracting from its meaning. They're not veering too far. They're literally almost paraphrasing. They're trying to say the same thing so that they're as close as possible, and their synthesis doesn't end up having an interpretation of what the author is trying to make out of it. It's staying true to what the papers are interpreting. And so yeah, sometimes you don't really have to change it that much, like, well, in this case, fear of the unknown and MRI scanning as a bodily encounter. These are actually there's a little bit of interpretation here. They're saying, well, if you have a fear of the unknown when you go into an MRI, what that tells you is that you don't know what it is until you do it. So they're kind of reading between lines and saying, well, You need to experience it to understand what it's going to be like, and then you won't have that fear anymore. So there's a little bit of reading between the lines, but not so much that you're going to detract and change its meaning. As an overall concept, you want to stay as close as possible and adequately reflect that, because otherwise you're going to change the arguments and your entire DAG falls apart, because now you're just making up, adding in your own arguments, chopping and changing things. It's going to stop making sense. And at the end of the day, when you do your synthesis, you want to have everything you need so that when you write your paper, this kind of framework is 100% transparent. And I think that is everything I need to go through for today. If there's any questions, anything in the chat or whatever, just email me. Let me know. Much obliged. Thanks. Cool. Cool. Also, guys, don't forget to fill in the feedback form. I want to go. Did you put that in?
Hi, yeah, I've just put the link in.
Cool. Okay. Like I said, if there's any questions, anything that comes to mind, you're always welcome to talk to me about it in mentorship scheme, or email me, or just put it in the chat now. You can still put stuff in the chat later, because I can come back to it. This is an open meeting, so that's also a possibility. But yeah, if there's anything else, do let me know. But otherwise, we're gonna wrap up for today.